Hi, in this question we are given Q started to move from point B towards A. So we have 2 points effectively here, point A and point B. First of all, Q started to move from point B towards A exactly 1 hour after P started from A. So P started from A towards B, Q started from B towards A 1 hour after P. Okay, fine. Q's speed was twice that of P. So let's say Q is traveling at a speed of 2s kilometers per hour, whereas P's speed is s kilometers per hour. When P had covered 1/6 of the distance, so let's say by the time P reaches here, 1/6 of the whole distance, 1/6 of the distance, let's say the total distance is D. So when P had covered 1/6 of the distance between A and B, Q had also covered the same distance. So Q has also covered 1/6 of the distance in the same time. So because the distance is constant, distance traveled by P and Q is constant, we can say that the ratio of their speeds is reciprocal to the ratio of their time taken. Distance traveled by P is 1/6 of D, distance traveled by Q is also 1/6 of D. So from here we can say speed of P upon speed of Q is equal to time taken by Q upon time taken by P here. Okay, now the point where P and Q would meet, okay, this is one thing, but let's just look at questions. What are the questions actually? The point where P and Q would meet is closer to A, exactly between A and B, closer to B, or they will not meet at all. Obviously they will meet, they are going towards each other, right? At the same time, both of them are at equidistance from B and A. Now obviously because Q is traveling faster than P, by the time they meet, Q would have traveled more distance than P because Q is faster. If the speeds were same, they would have met exactly at the midpoint of these 2 points. But since Q is faster, Q would have traveled more distance than P. Hence they would be closer to A and farther from B. So they will meet closer to A rather than B. So this question can be solved without even solving anything, or it can be answered without solving much, right? So the answer will be obviously A. Now how many hours would P take to reach B? That's the question. Fine. So we know ratio of speeds will be reciprocal to the time taken. Now speed of P is s and speed of Q is 2s, which is equal to time taken by Q. So Q starts 1 hour after P. That means P takes 1 hour more than Q. So let's say time taken by Q is T hours and time taken by P will be T plus 1 hours. It takes P T plus 1 hours to reach this point, and it takes Q T hours to reach this point. Okay. So we have SS gets cancelled out, we have 1 upon 2 is T upon T plus 1. So we have 2T is equal to T plus 1, that gives us T is equal to 1 hour. Okay, T is equal to 1 hour. What this effectively means is that P takes 1 plus 1, 2 hours to travel 1/6 of the distance. Now if P takes 2 hours to travel 1/6 of the distance, hence to travel the full distance D, it would take him 6 into 2, 12 hours, right? So P would take 12 hours, option D, to travel the whole distance from A to B. And now coming to the last question in this set, how many more hours would P compared to Q take to complete this journey? So we already know P will take 12 hours. And now since speed of Q is twice the speed of P, it means time taken by Q will be half of this, that means 6 hours. So Q will take 6 hours to travel the whole distance, and P takes 12 hours to travel the whole distance. Hence the difference in their time taken, we have to figure out the difference, right? How many more hours would P compared to Q take to complete the journey? So the difference in the time taken will be 12 minus 6, which is 6 hours. Hence option C is the right answer here. Thank you.